Now, here I want us to consider a very interesting paper. Okay, it's University of Cambridge International Examinations, General Certificate of Education, Advanced Subsidiary Level, and Advanced Level. Now, it's paper 1, that's pure mathematics 1, and the code is 9709/11, which was taken between the 10th month and the 11th month of 2011. And we consider question 11. So that's how interesting it is. And let's see if the solution will be as interesting as the coincidences that the question itself exhibits. So functions f and g are defined by f actually is the function f of x is that such that x is defined by this within the range 0 to 2 included. 0 and 2 included within that range. Then the function g has x defined just as x, again within the range 0 to 10 included. I'm saying included because we see less than or equal to. Actually, x is less than or equal to 2 and x is greater than or equal to 0 for the function f, and for the function g, x is greater than or equal to 0 or x is less than or equal to 10. So Roman 1, express f of x in the form a into x plus b squared plus c, where a, b, and c are constants, 3 marks. Roman 2, state the range of f, 1 mark. State the domain of f inverse, that's another 1 mark. Then sketch on the same diagram the graphs of y is equal to f of x, y is equal to g of x, and y is equal to f inverse of x, making clear the relationship between the graphs. Then Roman 5, find an expression for f, actually inverse of f of x. That's how we read it. So let's see. When we look at the equation that indicated that is unique, in the sense that it is question 11, which was taken on 11th of 2011 on the 11th month. So that's how unique this question is. And now let's see. Functions f and g are defined by, so the function f is defined as x is 2x squared minus 8x plus 10. And the range that we are given is for x lying between 0 and 2. X lies between 0 and 2 for that function f. Then there is a function g, which we also given, and g is just x. G is just x. Okay, and within the range 0, x lying between 0 to 10 for the second function. So those are 2 functions. Then we are told, express f of x in the form, a into x plus b squared plus c, where a, b, and c are constants. Where a, b, and c are constant. Now, so, and that is Roman 1. So this is how we go about it. So first we see that we have 2x squared minus 8x plus 10. And we are to express it in the form a into x plus b squared plus c. So we need to remember completing the square method. Now, and again, using completing the square method, we'll see later that it is possible to derive the quadratic formula. So here, this is how we go about it. I see that this bit, I can write it so that I write it as 2 into x squared minus 4x plus 10. So that's another way of written it. But I want to consider whatever is inside. I want to complete the square for what is inside. So for x squared minus 4x, if I'm to complete the square, it will be x squared minus 4x plus 4, where 4 is the square of half of this. Half of this is 2. Squared is 4. Plus 4 minus 4. So that half I've added it and also subtracted it. By adding and subtracting is like it's like I've done nothing, but at least I've done something, because at least I now also have freedom to factorize. So I carry the whole of this as it is and bring it here. So that will give me 2 into x squared minus 4x plus 4 minus 4 plus 10, like that, plus 10. Let me open up the brackets. If I open up the brackets, I'll be having 2x squared minus 8x plus 8 minus 8 plus 10. Plus 10. Then I look at this part, that part there. Then I have 2x squared minus 8x plus 8. That is this part only. So that part gives me, if I'm to factorize this, then I'll be having first, I'm actually looking for two values whose product is 16 and sum is -8. That's 1, 4. So I'll be having 2x squared minus 4x plus 8, like that. So I can come here and say 2x to be outside, then I'll be having x. If 2x is inside outside, then I'll be having x. I'll be having x inside here minus 2 then you have minus 4 to x minus 2, like that. That means that I have 2x minus 4 into x minus 2. And that's like saying 2 into x minus 2 squared. Since this, if I factorize 2 here, I'll be having 2 into x minus 2 times x minus 2. So this is x squared. So 2 into x squared minus that. So that is this. Then I come and bring it. So if that's what I have, then it means that now I have here 2 into x minus 2 squared plus 2. Because now this was the whole of this, but this is minus 8 plus 10, so that gives me plus 2. And having this now we have 2 into x minus 2 squared plus 2. I've already expressed it in the form that is wanted, that is required. So let me see. I hope you followed. So if I have, you can. Yes. So this should mean that our A is, so it is, the answer we have is that 2 into x minus 2 squared plus 2. So A is 2, B is minus 2, and C is 2. This, and that. So those are them. That's how you will write it. Then we are told, state the range of f. Now that is Roman 2. That is Roman 2. State the range of f, the function f. Now, the function f, now we see that the function f is this. The function f is now 2 into x minus 2 squared plus 2. Now, if you observe this, then you'll see that it's a parabola that is making a U shape. If you look at this, the coefficient, the sign of the coefficient here, and so in that case, what we have here is that, and again, we are also given the limit to be x should just be between 0 and 2. Just be between 0, 0 and 2. So if we look at this particular function, it means that the minimum, if it's making a U-turn, because if it's a parabola of the shape, it means that this is the point. This should be the vertex. That is the vertex. And it's the minimum. And that minimum happens to be 2. It's the minimum. Because you see that if I substitute, if I put 0 here, if I take x to be 2, then all of this will be 0 and I'll be remaining with 2. So it means that when x is 2, y is 2. So we have that. So what I'll say is that the expression that shows that f of x is a parabola that opens upwards as such, with its vertex at x is 2. So at x is 2, we can clearly see that at x is 2, f of x is clearly 2. By simply substituting 2 here, then you will still find f of x to be 2. Okay? Then since the parabola opens upwards and the coefficient of this 2 here is positive, the minimum value of f of x is 2. That's the minimum here, the minimum we have. So it reduces until it cannot reduce any further, then starts to go up. But you see, going up is limited by this. All right. So in this case, then what we see is that the range of f, we can easily say that the lower boundary of f is defined. The lower boundary of f is defined and it is 2. So we will say here 2, we give it this square bracket. Now, square bracket here should mean that it is closed, or it should mean that 2 is contained. At that particular point, 2 is also a point that is counted. So at least it is bounded. On the lower end, the function is bounded. But because since it should only, x should only be between 0 and 2, if I take 2, then it's 0. Now, should I take 3? Then I'm already beyond this. Yes, I'm beyond this range. But then let's take a case where now, okay, just a minute. If I take 2, it is 0. If I take 1, it is reducing. If I take 1, it will be minus 1 squared, which is 1. So 2 plus 2, which is 4. So y will be 4. So in that case, what we have here is that we see that now the lower boundary is the one I've defined as 2, and we have said it contains 2. And it's just ending at that, so I'm not going to go beyond there. Then, coming this end, we see that we can change x in many ways, so that x can even be infinity. I can take x to be 3, 4, 5, 6, 7, in which case it will be increasing without any boundary. So I will call this infinity, but leave it open because I don't know. I don't know where it's stopping. So I say the range is 2 to infinity. Roman 3. Sketch on the same diagram the graphs of y is equal to f of x, y is equal to g of x, and y is equal to inverse of f of x, making clear the relationship between the graphs. Now, that is an assignment I want you to attempt on your own, and I'll guide you on how to. So the function f of x is this. So if you want to draw it, then you will first say, so I'm just guiding you on how to go about Roman 3. So Roman 3, I'll now say y is equal to 2x squared minus 8x plus 10. Then I'll definitely do a grid xy like that, because I want to plot. And I see that when x is 0, y is 10. Y is 10. And when y is 0, then we should be having the roots of this. Like that. Then you plot. You again come and find this. This simply means that y is equal to x. This is y. This is the line y is equal to x. So that if it were a transformation, but then the line y is equal to x is like this. So if it were the mirror line, then it would. If it is the mirror line, then it would be reflecting things this end. It's a reflection line. So I say the domain of the inverse function f of x, we are asked to get the domain. Sketch the under there. Okay, making clear. Oh no, I first state the domain of f inverse. The domain of f inverse is just this. The domain of f inverse is just this, because this was the domain of f. If the domain of f is this, then the domain of f inverse remains just that. So the domain of f inverse is this. So Roman 4 is where we were asked to get sketch on the same diagram the graphs. So I've said this is how you go about it. That's how you do. Now for the second part, you would also draw the grid like xy. Then x is 1 when y is 1. X is 2 when y is 2. X is 3 when y is 3. Then you draw it like that. Then you draw again for the f inverse. You sketch again for the f inverse, and you shall observe the properties having drawn. And what I'm saying is, y is equal to f of x is a parabola opening upwards with the vertex at 2. 2. So what we see is that this point x is 2 at that point, and y is also 2. That's what we are saying. And the domain is 0 to 2. Now, y is equal to g of x, which is this. Is the line y is equal to x, which is a straight line passing through the origin with a slope of 1. Now, you should see that if it passes through the origin and it is 1, 1, 2, 2. When x is 1, y is 1. When x is 2, y is 2. When it's 3, y is 3. That means that if you are to get the slope will be unity, because the changes go with the same magnitude. So it's valid between, and that is valid between x is 0 to x is 10. So you continue with this. You should have started with when it's 0, because this is x is greater than or equal to 0. So we should start with at a point where it is 0, because it's passing through the origin. Now, for y is equal to the inverse of x is the reflection of the original function across the line y is equal to x. So what we are saying that if this is the function of f of x, if you reflect this along this line, so whatever you had drawn, it comes this end, because now this acts, it will act as a mirror line. And that you'll see, having plotted, you'll see that if you plot those three, you'll realize that that line just passes like that. Then you have your parabola, and you also have your inverse, and then you'll see what I'm talking about. So is the reflection of the original function across the line y is equal to x. The graph of f inverse will be the reflection, f inverse will be the reflection of y is equal to x, f of x across this. So this will be reflected along this line. So that if the curve, that parabola maybe looked like this, then we will be expecting another one here. If reflected, another image of this will be CDS, because this acts like a mirror. Okay. So that's an assignment. You draw it and see, you confirm what I've just mentioned. Now, find an expression for f inverse of x. 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 So if I have this, so that is Roman form. Ry is equal to 2x squared minus 8x plus 10. So I need to make x the subject. And how do I do that? I think I'd simplified this. So if I had simplified it, then there's no need to come here again. It was 2 into x minus 2 squared plus 2. So I want to make x the subject. And this will just mean that 2 into x minus 2 squared is equal to y minus 2. Is equal to y minus 2. So x minus 2 squared is equal to y minus 2 over 2. X minus 2 is then square root of y minus 2 over 2. And then I have x to be 2 plus or minus root of y minus 2 over 2. But because x is restricted within this, if I take a positive value, then I'll be having a value which has gone beyond, shall have gone beyond. So I'm not supposed to pick a value of x which is more than 2 by this. So it means the only thing that can happen is when all of this is 0, or I take a negative sign. So that implies that my x will then be 2 minus root of y minus 2 over 2. And thus, if that is the case, then we say the inverse function of f of x, just now replace, actually substitute where there is y, you put x, and where there is x, you put y. So that means that f inverse of x will be 2 minus root of x minus 2 over 2. X minus 2, x minus 2 over 2, x minus 2 over 2. So that is the answer to that particular part. So just take your time from the beginning up to where we have stopped. You will see the sense, and this is functions, and it is tested in pure mathematics paper 1. So up to there, follow me in my next video.